Okay, so I'm Apar and I've been working on Alpenglow. So like we are looking into like rotor different implementation. So first, like I'll just explain like how the block and shader layer like works, and then proceed further. So we have a block, and then it splits into slices, and it acts as a payload that goes into the shredder. So that slice splits into like 32 shreds, and then we have a total output of 64 shreds, like 32 are data shreds and 32 are parity shreds, and its maximum of 64 shreds. So like the values in Rust are like 30 32 maximum of data shreds, and then total shreds are 64, and maximum data per shred is like 1024 bytes. And uh, like how this is how we can get the padding and the data per slice, removing the padding like the last byte. And yeah, and the shredder function, like how it works in Rust, the Rust implementation, we have like header, payload, and then num data for like the data shreds, and for num coding for coding shreds. And this generates, we get the output as data shreds and coding shreds. So initially we like have a check for payload length. Is it less than the data per slice? And then we add padding to it. Padding is like at the end we will have how many bytes we have. Like padding will tell us that during deshredding, like we know, like we remove the padding at the end and then truncate using that padding which is stored in the byte. So yeah, and then we get the shred bytes. Yeah, and shred byte is like splitting the payload into chunks. Like we have 32 here as data shreds, and for example, if we have 17 as the payload, then it will split into 32 chunks, and yeah, we will have probably 4 or 5 as the output, like it's sealed. So then we do the encoding part with Reed Solomon, and we get coding shreds here, like the coding part here, and then we wrap this whole thing in the data chunks into data shreds, and here, and coding shreds into coding chunks into coding shreds, and then we enumerate and return both the vectors. Yeah, now we have the shreds. Like now how will the shreds go into the network, like distribute all over the network? So this is like we're looking into this part. So like how will the leader send these shreds? So leader has the shreds. Leader will send these shreds to the relay nodes, and then relay node will broadcast the shreds across the network except leader and themselves, and then verify the verification of the shreds will be done on the receiving nodes, like just to have some extra save some latency. So here in the white paper, it's specifically not mentioned. Like you can look at the grammar, you will get the idea. Like they are looking into option where the leader selects a single relayer for a single shred, and like how it goes, like leader has a shred, and then it goes to single relayer, and then that relayer broadcasts to like all the nodes. But we can look into another option. I think most of the people who read the white paper are thinking like this is how it is done, but I don't think this is how it is done. Like, but yeah, I'm still looking into this. Like the leader can send that particular shred to multiple relayers, and then can be sent further. So yeah, like we're still like looking at the benchmark. Like we still got a few questions to ask from Roger, so that we can do the benchmarking. And yeah, and if we look into the option that is done in the Rust implementation, it's the option 1, like where the block is split into slice, and then we get shreds, and then the lifetime of a single shred is like leader sends it to a relayer, then all the nodes, like just to give you a better imagination. And the implementation is we have to first choose a sampling strategy. So here, like in the white paper, it is mentioned like we choose from like the uh, s- validators who have more stake to the less stake. There are multiple strategies like uniform, and like you can also combine few strategies to have a bit of randomness, so that every time like we do not select the stake weight like who have more stake. So but for the time being, like I'll just choose the stake weight where we go from high to low. Yeah. So here, like we have new validator as a function, and this function builds a weight index from validator stakes and it unwraps. And then for the sample, like we draw an index with replacement according to the stake proportion, and then return a validator ID according to their stake proportion. And similarly, we sample an index and returns their validator index, like from for the sample info, like the it will give validator info. So then we can using that specific sample strategy, we can relay, like it'll make a relay function, and then this function can create from slot number and then shred like create seeds from slot number and shred index, and then generate a random number, and using and then choose a sampling strategy to select the validator, to give an validator like to select an validator. So yeah, so this is like, so yeah, we can make multiple sample strategies for that. And then we can, then the leader uses this specific function to then relay the shreds, the like selecting the validator. Like, we are using this function that we created earlier, and then convert this shred into a network format, like message format, and then send it directly to the disseminator address. And yeah, like the purpose is to, instead of broadcasting to all the validator, like leader, instead of broadcasting to all the validators, leader will just send it to specific relays, so that the leader has less load. So this is the reason behind the rotor. And how the relayers will broadcast is a bit like the relayers will use the same function in this implementation. So they will like broadcast they will broadcast to all the validators except leader and itself. And yeah, they will like check if like they are equal to leader, or relay goes for continue. If not, then they will broadcast. Yeah. And this is it. Like specifically uses, I used Alpenglow white paper and the Rust implementation. Yeah, thank you.
Awesome.